So first of all, we'll start the basic revision about this torsion and then we'll go for every single solution. So what is the main formulas you should keep in your mind while revising torsion or while doing the numericals of torsion? So as I told you, this trick T by, let me change the color, this T by J Tej, tau by R Tyohar, G theta by L Geo theta lal. So this was my trick, Tej Tyohar Geo theta lal. Okay, so with this trick you can remember this torsion equation. Now what is T here? This T is the torque applied on any shaft which has radius R. It means what? This part is best suited for circular shaft. If you have circular shaft like this, and suppose this is the shaft both side, and suppose at this point it is hinged and fixed, and you are applying any amount of torque. So first you should know what is torque. Actually torque is nothing but, right now what kind of torque you're applying here, the symbol you will give like this kind of arrow. Okay, so see, torque is nothing but moment of force. Okay, when you calculate moment of force, that is known as torque. Right, now what is force here? You know very well what is force. So suppose, what is difference between this torque and this force? What is the difference? See, suppose you have any bottle, okay, and you want to open the bottle. So you will use two fingers by your hand. One finger you will keep here and other finger you will keep here, and one finger you will push in forward direction and one finger you will push in backward direction. Okay, so with respect to center, you will be having equal distance for both the forces. So you are applying two forces. You are applying two forces on a particular distance, right? So with respect to the center, this cap of the bottle will rotate and you can open the bottle. So you are applying force. Reality is you are applying force, but the way you are applying the force, that gives you torque, moment of force, you can say. Okay, so this is what my main concept is. Here when you are applying the torque, how will you apply the torque? You can apply this kind of concept. See, you have your hand, you put one finger here and you put one finger at the bottom, right? And you twist that, rotate the torque like this. So again you are applying one force here, right? So with respect to center, you have the distance here. I mean to say that this T is torque. So in exam they will directly be giving you the value of torque. So torque will always be given in Newton meter. Okay, how will you convert any force into torque? So see, when you have one force and you multiply with the perpendicular distance, then you will be getting moment of force, correct? So here you are having two forces. One force is acting in this direction, one force acting in this direction. Actually see, there is something called torque and there is something called couple. See, torque is different and couple is different. Okay, what is torque and what is couple? Couple is nothing but this effect where you are applying two equal forces like this with a particular distance r and r. So this is called couple. So sometimes you can apply two forces to produce the rotation. Sometimes by only one force you can produce the rotation. So these are the basic differences. Now you see here we are applying a torque here, so that torque will be in Newton meter. Newton meter is SI unit. Today one of my students, she was solving some problem in propulsion, aircraft propulsion, but she was not keeping the values in SI unit. She was doing complete, like very good explanation, like complete explanation, but she was not using units in SI, so she was getting wrong answer. So SI unit should be in your mind. Now what is J here? J is the polar moment of inertia. So you should directly remember the formula for the J. What is J formula? I will just erase this part. J is nothing but polar moment of inertia. So already I have explained, if you will watch my complete video for the torsion, there I have explained how to calculate polar moment of inertia. So J formula is nothing but pi by, yes Dhruv, you can write down. Very good, excellent. Pi d power 4 32. Actually this is the diameter. Okay, I will write down. See, sometimes in some textbooks or some teachers they write IP. This P is the polar and I is moment of inertia. So polar moment of inertia. In some textbooks, some teachers they write J for the same thing, right? So pi by 32 sometimes you can write d square, sometimes they write capital D, means this thing is representing diameter of the shaft. This is representing diameter of the shaft. Now if suppose if you have two different hollow shaft, if you have, imagine if you have hollow shaft, oh sorry 4, yes, thank you, true. So it is 4 actually. Suppose you have hollow shaft, then in that case what will you do? Suppose one diameter is this and one diameter is this, and in the middle part material is not present. Sorry, only here you have material present. So in that case what will happen? If there is no material, if there is no mass, that will not produce any kind of moment of inertia. There we cannot calculate, right? So in that case you have to subtract the bigger moment of inertia with the smaller moment of inertia. Okay, it means if I'll say that the bigger diameter is capital D and the smaller diameter is small d, then pi d power 4 by 32 minus pi d power 4 by 32. You will calculate this and you will be finding out the resultant moment of inertia of the hollow shaft. So these are the basic things. Okay, but if you come to the formula, T by J, tau by R, G theta by L. So this is T. This T is your torque, clear. This J is your polar moment of inertia, clear. What about this tau? This tau is actually your shear stress. Whenever you apply torque, shear stress comes into picture. So that shear stress will be acting on a particular radius. Okay, so that radius is R. Now what my point is? My point is like suppose, okay, this tau is already these things, basic details I have given in the main video course. So already you have revised, so no problem. You understand what is tau, shear stress, because if I'll go into detail again into shear stress, it will again consume time. Now you go for the radius R. What is radius R? So radius R means suppose you have this thing. So from the center you can have this this height or this height or this height, like so here you will be having one radius, or here you will be having one radius, or the complete radius, the full radius, like this. So R will be there. Now what is G, what is theta, what is L? L is the length of the shaft, and what is theta? Theta is like when you will apply the torque, then suppose this point, so this point will shift by a certain angle theta, correct? So that is theta. So again we have two things, one is called theta and one is called phi. So these things we have covered in the video series properly, so you should revise that. Now you go for the L. Okay, L is clear. What do you go for the G? What is G here? So you know our stress is proportional to strain. It depends what kind of stress we are dealing, according to that we'll be having that kind of strain. In real life we calculate strain by using strain gauges, and by applying Hooke's law we can calculate stresses. So stress is proportional to strain, this part is clear, but when you will remove the proportionality sign, then you will be getting elastic constants, right? So that elastic constant is E, G, or bulk modulus K or B, whatever is symbol we use. In some textbooks the G they replace by C. Okay, for Young's modulus they always use capital E. So this G value what you are seeing, it is known as, this G value is here, that is known as shear modulus or modulus of rigidity. Like so now I will take my first example, and this is selected, like very selected problem from the GATE mechanical. So you see here, I will read the question first. Question is, I'll change the color. Question is, the compound shaft is built in at the two ends. Now you see they are saying compound shaft. So compound shaft means you can see in the diagram, here you have length L and here you have length L. This diameter is D, this diameter is 2D. Okay, and you also see this side also it is fixed. See, this built-in name is there, na, this word, this is also known as fixed. Okay, you see it is subjected to a twisting moment T. What I am saying as torque, same thing they are saying as twisting moment. Now see, if you are calculating moment of force, right, so you may get two types of moment. This moment you can get two types. You can get bending moment and you can get twisting moment. Okay, for example, if you have a beam here and it is fixed here, if you apply load like this, then multiply with this length, then you will be getting bending moment here. So that is also moment of force. And in same way, torque, what I am saying, twisting moment, that is also moment of force. So twisting moment, but effects are different. Effects are different. In bending, your beam will bend like this. In torsion, your beam will not bend, it will twist. So that is the meaning of twisting moment T. Okay, at the middle means exactly here, there you can see here they are applying the twisting moment. So it is like this. like this kind of twisting moment is there. So entire, this will also rotate like this will also rotate like this. I mean, the complete rotation is not possible, but it will be having sense that okay, there is a twist. What is the ratio of the reaction torques T1 and T2 at the end? Now get my point. See guys, because we have applied torque like this, right? We have applied torque like this. So because of this, what will happen? When this object will rotate like this, so this side we have built in, means fixed. So what will happen? This wall or whatever rigid thing we have, this you can see, this will rotate maximum, this will rotate little bit minimum, this will rotate little bit more minimum, and this portion will not rotate at all. So why it is not rotating? Because the wall is, this side wall is there now, that is resisting the rotation. Okay, so this rod is having tendency to rotate like this. It means what? The wall will produce opposite torque, then only it can resist, right? So you can see in this diagram, you see arrow is like this, so it means this will go and rotate like this. So to counterbalance this, wall will produce opposite torque, so it is shown here. So that torque is T1 for the smaller diameter. In same way, when this guy will rotate like this, you can see this torque. So here we are rotating like this. So to balance this rotation, the wall will produce like this. Okay, now done. So this is the diagram. Now how will you calculate this? So always keep in mind, main thing is, whenever they are asking the question for the twisting moment, you have a very beautiful trick. That trick is, any question you check, mostly you can say 95% this trick will work. What will happen? Any one thing will be constant in the equation. You have equation Tej, Tyohar, Geo, Theta, Lal. Okay, so in this equation, you see any one thing will be constant. Okay, so you can see properly, you can see torque is constant, no, torque is not constant. Here it is T1, here it is T2, it is not constant. Okay, next thing, J is constant, J is not constant. Here D, here 2D. Okay, what about the shear stress? Of course, shear stress will not be constant. Can we do something else? Anything will be there which is constant. So of course, one thing is constant. Exactly at this section, you have applied the torque. Okay, so at this joint, you can say the name as joint. At this joint, if this is bending by some theta angle, so exactly same theta angle, this will also bend. Okay, because this is joint now, this is joint. So suppose this point is there, this point is common for both. So if this point will shift this much here, so this shifting is common for both. So it means what? Exactly at the joint, same angle will come, correct? Exactly at the joint, same angle will come. So theta, what we use, that is for a particular length. It means what? Go for the basics of the chapter. Basics is, if you have a rod like this, and this length, I am saying in this direction, length is L, and you are applying torque like this. You have applied torque here, so this point will shift a particular distance. So if I will attach one more shaft here, so that point is common for both, right? So the angle of twist will be same. I hope you got. Dhruv, are you getting? And what I'm saying? Gaurav, clear? Okay. Okay, very good. So that's all. So what will I do? I will apply torsion equation for this guy also and for this guy also, and I will equate both. That's all done. And we can find out the ratio. So how can I do that? See, T by J, and now don't use the middle thing. No need to use middle thing. And you apply G theta by L, because we have nothing to do with that. Now you see, if you will go in this way, then find theta for the shaft 1, so that you say theta 1. So rearrange the equation. So multiply L this side and multiply G this side. So it will look like TL by GJ. And one more thing, guys, you should know the basics also. This GJ is having its own name. G is having separate name, J is having separate name, but when you multiply them, then their name changes. Okay, GJ is known as torsional rigidity, right? Like we have AI, we have EA, they all are having their separate names. That already I have covered in the main video. Okay, so you can see here the theta 1 value I am finding out TLGJ. So this T you put as TL T1, correct? G value you put G1. So if you are solving for the first shaft, but there is a problem. Problem is, for both the shafts, should we consider G1, G2 same or different? So if not given, then you consider same. If given, then G and G1, G2 will be different. Okay, done. So almost done, right? now you do one thing, go for the ratio. So you can clearly see your theta value, if I will write, it will look like TL divided by GJ. So 1 1 1 1. See, this is theta 1. So this should be equal to your theta 2. So theta 2 is nothing but T2 L2 divided by G2 J2, right? Okay. Now few things will get cancelled and few things will not get cancelled. So what are things will get cancelled? You cancel them. G1 G2 will get cancelled. Okay. L1 L2 will get cancelled. So we clearly see that T1 by T2 ratio we can find out. So this T1 is here and divide by this T2 is here, and J1 will go this side and J2 is already present here. So your ratio of T1 by T2 is nothing but it is the ratio of J1 by J2. Now J1 by J2 ratio, see one more thing, this kind of common mistakes will happen in GATE exam, very common mistake. What ratio they are asking? You should make sure they are asking T1 by T2 or they are asking T2 by T1. So what is the ratio of the reaction torques like T1 and T2? Okay, so it means this one. Let's calculate. So J1 by J2. Just now you know that what is the formula? Pi by 32 D1 square and pi by 32 D2 square. So these two guys will get cancelled out. This and this properly cancelled. It means what? D1 square and D2 square is the final answer. So now D1 square, if you'll go, it is simply a D. Okay, sorry, power 4 is there, guys, my mistake. Power 4. So in GATE exam you may you may also do this kind of mistakes. So yes, very good. So if you see D power 4 will get cancelled. So 1 by 2 power 4 will come. Final answer. So 2 power 4 if you will do, so 2 into 2 into 2 into 2. So 4 into 4, 16. So 1 by 16 will be the right answer. Now let's go for next question.